Hello students, today we are going to see problems on functions of bounded variation. Problem solving is very important to understand the concept of bounded variation. In the first problem, we have taken f of x as a constant function. I have given here f of x equal to k for all k belongs to R, where R denotes real numbers, and x we are taking from the closed interval a comma b. We have to check whether this function f of x is of bounded variation. We know that summation k equal to 1 to n modulus of del f k less than or equal to m greater than 0 and m belongs to R is the condition for a function f of x to be of bounded variation, and modulus of delta fk, which is equal to f of xk minus f of xk minus 1. First we have to partition this closed interval a comma b. Now I am making a partition a equal to x naught less than x1 less than x2, so on up to less than xn minus 1 less than xn, which is equal to b. Then our partition will have these elements x0, x1, x2, so on up to xn minus 1 comma xn. All this I have explained how to do all these things in the classroom itself. Now we are going to check whether the function f of x is of bounded variation. So I am going to find the value of summation k equal to 1 to n delta fk. I am going to find out this value, summation k equal to 1 to n modulus of delta fk. Okay, so summation k equal to 1 to n mod delta fk, which is equal to f of modulus of f of x1 minus f of x0 plus modulus of f of x2 minus f of x1 plus modulus of f of xn minus f of xn minus 1. So this is the definition for summation k equal to 1 to n modulus of del fk. Now if we see at the function initially, what is given is f of x equal to k for all x belongs to closed interval a comma b. So what we will get here is modulus of f of x1 value will be equal to k minus k plus modulus of k minus k plus so on up to modulus of, I have taken it as a small k minus k, which is equal to 0. That implies summation k equal to 1 to n mod del fk value is less than or equal to 0, which implies my function f of x equal to k, where x belongs to closed interval a comma b, is of bounded variation. Hope you understand the problem. Now next I am going to solve another problem. To make the concepts much clear, you have to solve more and more problems so that you understand the concept of bounded variation. Second problem is I am going to take my function f of x as f of x. Second problem, I am taking my function f of x equal to x belongs to closed interval a comma b. Again as usual I am writing the partition p equal to a, that is a is nothing but x0, comma x1 comma x2 so on up to xn minus 1 comma xn. And you know that this partition will follow this form: a which is equal to x naught less than x1 less than x2 less than x3 so on up to xn minus 1 less than xn. Now it is an increasing order, right? Then f of x value will be also f of x naught will be less than f of x1 will be less than f of x2 which is less than so on up to less than f of xn minus 1 less than f of xn. Since f of x equal to x, f of x naught will be equal to x naught, f of x1 will be equal to x1, f of x2 will be equal to x2. Now I have to check whether this function f of x is of bounded variation. For that I have to find out summation k equal to 1 to n modulus of del f k, right, which is equal to, as usual, f of x naught x1 f of x1 minus f of x naught plus modulus of f of x2 minus f of x1 plus so on up to plus modulus of f of xn minus f of x1 xn minus 1. So which is equal to f of x1 value is x1, right, modulus of x1 minus x naught plus modulus of x2 minus x1 plus modulus of x3 minus x2 plus so on up to plus modulus of xn minus 1. See, we are given f of x equal to x. Then what we will get is, for f of x1 I will get x1, for f of x naught I will get x naught. Same way I have followed in all the functions. Okay, hope you understood. Next what I have to take is, here I have x1 and x naught. Comparing these two values, I know that x1 is a bigger value when compared to x naught. And here also, when I compared x2 and x1, I know that x2 is a bigger value when compared to x1. Here also the same thing, x3 is the bigger value when compared to x2. Since we have made the partition in that form only, if you look at the partition, p equal to a x naught, that is nothing but x naught, next x1 x2 x3 so on to xn minus 1 comma xn. So this will be of the form like this: a equal to x naught less than x1 less than x2 less than x3 less than x4 so on up to less than xn minus 1 comma xn. So it is an increasing order. So when I find the value of this x1 minus x naught, I can write x1 minus x naught plus x2 minus x1 plus x3 minus x2 plus so on up to plus xn minus 1. So if I subtract, what I will get is x1 minus x naught plus x2 minus x1 plus so on up to plus xn minus 1. If I cancel out, plus x1 minus x1 will cancel, plus x2 minus x2 will cancel, so on. At the end I will get xn minus x naught, which is nothing but b minus a. Okay, so summation k equal to 1 to n mod del fk is equal to b minus a. B minus a is definitely a real number greater than 0 or equal to 0, greater than or equal to 0. Definitely it should be greater than or equal to 0. B minus a will be a real number greater than or equal to 0, which implies my function f of x equal to x is of bounded variation.